Alright, last problem of the fall 2011 exam 3. Pool ball striking side of a pool table. Coefficient restitution given. Determine the angle theta as shown. So this is very similar to one we did in lecture. We have to define or realize that this is our plane of contact. Okay, the pool table wall. Perpendicular to that is our line of impact. So I'm going to label this X and this Y just to keep things straight. In the X direction, in the plane of contact direction, we'll call that's Y. So velocity of the ball after or before is a velocity component after. Okay. So we can right away solve for the velocity of the ball. Y prime is equal to this, which is equal to this broken down into components. So let me redraw that. There's that. Okay. We're given this angle right here. And we're given this as 6. Alright, so breaking into components. Let's just do it this way. So we'll have a component going to the left and a component going down. Okay, this component will be 6 sine of 50. And this will be 6 cosine 50. This is our y direction, and it's actually negative. So it's going to be negative 6 cosine 50. Okay, if I calculate that, y component is going to be minus 6 times cosine 50. Halfway done, minus 3.857. Minus 3.857. Okay, the reason why I'm getting the velocities, of course, is because I want to determine the angle of this velocity vector, and I do that by having the two components. Okay, so that's half the problem. Line of impact direction. We have, which is our x direction. That was our y direction. And we will use E is equal to the negative of velocity ball in the x direction after minus velocity of wall after. Okay, velocity ball in the x before, velocity wall x. Of course, the wall is not moving, so those drop out, and we can get our equation for velocity of ball in the x direction afterwards is equal to the negative E times the velocity of ball in the x direction before, okay, which is this component. So it's minus 0.7 times minus 6 sine 50. Alright, let's see if that number comes out to be. Let's see, calculator, come back here. So it looks like my x velocity is going to be 0.7 times 6 times sine 50. 3.217. Meters. meters. Alright, so my velocity afterwards is coming down like this, and it's got an x component of 3.217 positive, and a y component going down of minus 3.857. Okay, we are looking for this angle, which is the same as that angle. So there's our theta on this triangle. Okay, so tangent of theta is equal to 3.217, which is my x1. Oh, let's write that a little bit better. Over 3.857. And calculator, where'd you go? Okay, so in my calculator I've got those stored, so it's going to be the arctangent of x divided by y in this case. Whoa, that's pretty scary. Not sure why that popped up. Alright, came out negative because the y was negative, but it's just going to be the absolute value of that, 39.8 degrees. Okay, not too bad.